You smell something, and before you've decided what it is, you're somewhere else. Another place, another time, someone who may no longer be alive, a room that no longer exists, a version of yourself that you haven't been for decades. You didn't choose to go there, you were taken, suddenly, completely, without warning, by a molecule. That's the thing I want to examine. Not the sentimentality of it, which is real but not the interesting part. The interesting part is the mechanism. Because the reason smell does this, and no other sense does it with the same force or the same involuntary quality, is specific, anatomical, and tells you something important about how the brain actually stores the past. Most people assume all senses work roughly the same way. They don't. Smell is architecturally different, and the difference explains everything. Let me start with what smell actually is, because the physical reality is stranger than most people realize. When you see something, photons, particles of light, travel from the object to your retina. You never touch what you see. There's a physical gap between you and the thing. What your visual system detects is radiation, electromagnetic energy that the object emits or reflects. When you hear something, pressure waves travel through air and move your eardrum. Again, you're detecting a transmitted disturbance, not the thing itself. The sound is a consequence of the source, separated from it by the medium it travels through. Smell is different. When you smell something, molecules, actual physical particles from the object, enter your nasal cavity and bind directly to receptor proteins on your olfactory neurons. You are chemically touching the thing you're smelling. When you smell bread baking, molecules of bread are inside your nose, making direct contact with your nervous system. This is not metaphor. This is molecular contact between the external world and your neurons. Olfaction is not remote sensing, it's direct chemical interaction. The machinery that processes this contact is extraordinary in its complexity. At the top of your nasal cavity, there's a patch of tissue about the size of a postage stamp, the olfactory epithelium, containing roughly 6 million olfactory receptor neurons. Humans have approximately 400 different types of olfactory receptors, each responsive to different molecular shapes and chemical properties. Most smells are not a single molecule. They're complex mixtures, dozens or hundreds of different molecules in particular proportions. The brain reads the pattern of activation across the receptor types, which are firing, which aren't, in what combination and intensity, and from that pattern constructs what you experience as a smell. It's combinatorial coding, not one receptor producing one smell, one pattern of activation across hundreds of receptors producing one smell. And here's the thing to hold on to. The molecules themselves are not intrinsically smelly. The smell, the experience of it, is the brain's interpretation of a pattern of chemical signals. The rose doesn't smell like roses, your brain does. The molecule is a key. The experience is what happens when the key turns in the right lock. Now the anatomy, because this is where everything changes. Every sense has a standard route to the brain. Sensory organ detects a signal. The signal travels to the thalamus, a structure deep in the brain that acts as the central relay station for sensory information. The thalamus processes, filters, and distributes the signal to the appropriate primary sensory cortex. From there, information moves to association areas, and eventually, if the stimulus is emotionally or mnemonically relevant, to the emotional and memory centers. This is how vision works, how hearing works, how touch works, how taste works. The thalamus is a gatekeeper. It's where attention gets allocated, where irrelevant signals get suppressed, where sensory information gets integrated and directed. Everything passes through it. Everything except one thing. Smell is the only sense that bypasses the thalamus entirely. Olfactory receptor neurons send their signals to the olfactory bulb, a structure that sits just above the nasal cavity at the base of the brain. From the olfactory bulb, signals go directly to the olfactory cortex. And from the olfactory cortex, there are direct projections, immediate anatomical connections to the amygdala and the hippocampus. The amygdala, the brain's rapid significance detector, the structure responsible for emotional tagging, for stamping experiences as emotionally important, for generating the physiological responses associated with strong emotion, directly connected to the olfactory system. The hippocampus, the structure most critical for forming and retrieving episodic memories. Memories of specific events in specific contexts with their temporal and spatial details. Also directly connected to the olfactory system. The consequence of this architecture is specific and important. When a smell arrives, it reaches the structures responsible for emotion and memory before it reaches the cortical structures responsible for conscious identification, language, and deliberate cognition. The emotional and mnemonic response comes before the verbal one. You don't consciously think, "This smells like my grandmother's kitchen," and then feel a wave of emotion. The wave comes first. The identification comes second. The architecture of the olfactory system guarantees this sequence. The feeling of being transported precedes the explanation of what transported you. Every other sense passes through the thalamic gatekeeper before it reaches emotion and memory. Smell doesn't. It's already there before the conscious mind has finished processing what it's receiving. In 1913, Marcel Proust described something that psychologists and neuroscientists have been studying ever since. A madeleine dipped in tea, a particular taste, which is partly smell, given that what we call flavor is predominantly olfactory, and suddenly an overwhelming, involuntary flood of memory, so complete it doesn't feel like remembering. It feels like being there. He called this involuntary memory. The term now is Proustian memory. What the research shows is that smell-triggered memories are genuinely different from memories triggered by other cues, not just subjectively, but in measurable ways. They are older. The reminiscence bump, the period of life from which we retain disproportionately vivid memories, differs by sense. For memories triggered by visual or verbal cues, the bump peaks in adolescence and early adulthood. For smell-triggered memories, the bump peaks in early childhood, before age 10. Smells reach further back than photographs. They are more emotional. Self-reported emotional intensity of smell-triggered memories is consistently higher than memories triggered by any other type of cue, even when the memories themselves are matched for content. The same event, remembered in response to a smell versus in response to a photograph, feels more emotionally intense in the smell condition. They feel more involuntary. The sense of being taken rather than going is stronger with olfactory cues than with any other sense. People describe smell-triggered memories as arriving rather than being retrieved. And they are frequently memories that haven't been thought about for a long time. Smell-triggered memories tend to be old and rarely accessed, which matters for a reason I'll come to shortly. Why older? Why more emotional? Why more involuntary? The architecture answers the first two. Direct amygdala connection means stronger emotional encoding from the moment of original experience. Strong emotional encoding means the memory is formed with higher fidelity and more associated detail. And because the olfactory system reaches deeper into childhood than other sensory systems, it's functional very early, even before birth, the earliest emotional memories are olfactory tagged in ways that visual memories may not be. The involuntary quality follows from the same architecture. Other senses go through deliberate processing before reaching emotion and memory. You can, to some extent, choose what to attend to, choose what to retrieve. Smell bypasses that control layer. There's no deliberation between the molecule and the emotion. The gatekeeper isn't there. Here's the part that changes how you think about memory itself. The dominant finding of memory research for the last 50 years is not intuitive, and most people resist it when they first encounter it. Memory is not a recording, it is reconstructive. Every time you retrieve a memory, you partially rebuild it. You reactivate a pattern of neural activity that was established during the original experience. But that pattern is influenced by what you currently know, your current emotional state, your current expectations, information you've encountered since the original event. The memory that comes out is not identical to the one that went in. This has been demonstrated with uncomfortable rigor. Eyewitness testimony changes over time, predictably in the direction of subsequent suggestion. Post-event information contaminates recollection. People incorporate things they heard or read after an event into their memory of it. False memories can be implanted, entirely fabricated recollections of events that never occurred, with surprising ease. The confidence a person has in a memory is not reliably correlated with its accuracy. Memory is a reconstruction every time, not a playback. Now here's the question. If memory is reconstructive, why do smell-triggered memories feel so complete, so vivid, so much like going back rather than imagining? Two possibilities, and they're not mutually exclusive. First, smell-triggered memories may be retrieved less frequently than other memories. You look at old photographs regularly. Photographs function as deliberate retrieval cues. You encounter music from your past regularly. You don't regularly encounter the specific smell of your grandmother's kitchen. Because smell-triggered memories are rarely retrieved, they are rarely reconsolidated, rarely subject to the reconstruction process that gradually modifies other memories. They arrive fresher because they've been touched less. Second, the vividness may be partly a product of amygdala involvement rather than genuine accuracy. Strong emotional activation at the moment of retrieval creates the feeling of intensity and completeness. The sensation of going back is generated partly by the emotional quality of the retrieval, not only by the accuracy of its detail. These two explanations produce different predictions about the actual fidelity of smell-triggered memories versus their felt fidelity. The research hasn't fully resolved this. What's clear is that smell-triggered memories feel more accurate and more complete. Whether they are more accurate is a harder question. There's an irony here. The sense that produces the most powerful feeling of direct access to the past may be giving you the most honest, preserved version of a memory. Or it may be generating the most emotionally saturated reconstruction. The feeling is the same either way. Distinguishing genuine fidelity from the sensation of fidelity is genuinely difficult, and the tools we have don't fully separate them. Why do the smells of early life have the deepest hold? The olfactory system is among the earliest sensory systems to develop. It's functional before birth. Newborns recognize their mother's scent within hours. While vision is still blurry and hearing is still calibrating, the olfactory system is already processing and associating. First encoding has a specific advantage. The first time a smell is encountered without prior association, it forms connections to the context, the emotional state, the people present, the time of day, the temperature of the room, that subsequent encounters don't replicate. The second time you smell something, your brain already has an established association. The encoding is different. The first association is primary in a way that later associations aren't. This creates a specific asymmetry across a lifetime. The smells of early childhood, when almost everything was being encountered for the first time, when the world was being encoded at high resolution because everything was novel, carry associations formed during a period of maximum olfactory learning. The smells of middle age don't carry that weight, even when the associated experiences are objectively more significant. The young brain is also more plastic. Synaptic connections form more readily, more durably. The olfactory memory connections established in early childhood may be structurally more robust than those formed later. Not necessarily more accurate, more durable. They persist with less maintenance. And the amygdala's involvement is heightened during emotional experiences. Childhood is a period of heightened emotional intensity, not because children are more sentimental, but because more of the world is new. More of it triggers significance responses. More of it is emotionally tagged at the moment of encoding. The result? A particular soap, a particular food, the inside of a particular car, a garden in summer. These smells, encountered first in early childhood, carry emotional associations that were formed when the olfactory system was most plastic, when the amygdala was most active, when almost everything was being encoded for the first time. That combination doesn't repeat. Let me be precise about what's happening when a smell takes you back in time, because the precision matters and the common description is not quite right. A molecule, a specific arrangement of atoms, a particular shape that fits a particular receptor protein, triggers a cascade that activates patterns of neural connection established during a past experience. The emotion arrives. Then the memory forms. Then, for a moment, something that feels like presence, like being in a place that no longer exists, with a person who may no longer be alive, being a version of yourself that you haven't been for years. The past is not stored somewhere. It doesn't exist in a physical location that you can access. It exists, to the extent it exists at all, as patterns of synaptic weighting in the brain, established during the original experience and maintained since. The molecule doesn't contain the memory, it activates the pattern. When a smell transports you, you're not accessing the past. There is no past to access. What you are doing is reconstructing it, instantiating in the present moment a pattern of neural activity that was first assembled during the original event. The sensation of going back is real. The going back is not. The past is not a place. It is a pattern. And for a moment, the molecule made your brain run the pattern again. I have spent a long career insisting on precision. Call things what they are. Don't mistake the description for the thing. Don't mistake the feeling for the fact. The smell doesn't take you back in time. Nothing takes you back in time. The physics doesn't permit it, and even if it did, there would be nothing to go back to. The past is not preserved anywhere outside the nervous systems of people who experienced it. What the smell does is reconstruct from molecular information and neural architecture something that feels indistinguishable from being there. The reconstruction is complete enough that the feeling is of presence rather than memory. And that reconstruction, using a molecule as the key, is, I think, more extraordinary than the romantic version. Because the romantic version says the smell preserves the moment. The accurate version says the moment was preserved, imperfectly but durably, in synaptic connections, and a molecule just told your brain to run those connections again. The person you briefly return to is not in the smell. They are in you. They always were. That precision makes it more interesting, not less. You are not remembering, you are briefly becoming someone who was there.